Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over magic numbers. So with magic numbers, we talked about in my last video how the neutron to proton ratio is an indicator of the stability of a nucleus, but also not only the ratio but the actual numbers of protons and neutrons also affect the stability of the nucleus. So here I have a table in which it shows the number of protons, number of neutrons, and the number of nuclides. And here are the number of stable nuclides, I should add. So here you'll see that if the number of protons is even and the number of neutrons is even, in this situation, we have 157 different stable isotopes that have an even number of neutrons and protons. For those isotopes that have, or nuclides that have an even number of protons and an odd number of neutrons, we have about 53 of those. And we have about 50 stable nuclides that have an odd number of protons and an even number of neutrons. And we have only 5 stable nuclides that have both odd and odd for number of protons and neutrons. And so what this is telling us is that even numbers of protons and neutrons add to the stability of the nuclide itself. And we can see that here. The fact that we have well over 100 nuclides have even and even. So why is this? So the reason is that, as I said in my previous video, nucleons occupy energy levels in the nucleus, just like in or similar to the way in which electrons occupy different energy levels in the atom. So just as certain numbers of electrons are uniquely stable, so in this case we're thinking about in particular noble gases. So for example, noble gases are particularly stable. They have a certain number of electrons that allow them to be stable. So 2, 10, right? So helium has 2 electrons total. Neon has 10 electrons. Total, and so on. So going down, you have 18, 36, 54, and so on. So these numbers are special for the particular atoms for the electrons. So atoms, in the same way, atoms with certain numbers of nucleons in the nucleus are also uniquely stable. So if your number of protons or neutrons is either equal to 2 or 8, 20, 28, 50, 82, you're going to be uniquely stable. And if you have a number of neutrons is equal to 126. So these numbers here we refer to as the magic numbers. So these numbers, these actual numbers of protons or neutrons, add to the stability of the nucleus. So nucleons also have a tendency to pair like electrons. So just like electrons, remember, they pair up and that adds to stability. Remember, electrons pair an opposite spin up, spin down, and that adds to the stability. And so in the same way, nucleons, I don't think they have spin, but they do pair up. And so nucleons have a tendency to pair up like electrons, and this also contributes to the abundance of the stability, the abundance of the stable isotopes or nuclides, I should say, with even numbers of nucleons. Why? Because when you pair up, you have 2. That's an even number. So if you like to pair up, then you're going to have a tendency to have even numbers of protons and neutrons in your nucleus. And so that would be explaining why we see these even numbers. And so I hope this video helps. That's all I have for this video. If you like this video, if this was an interesting video, if you learned something from this video, then please, by all means, like the video. Hit that like button right there. Hit it. Smash that like button. Also, make sure you subscribe to my channel. Hit that notification bell. And when you hit the notification bell, make sure you hit all so you can be notified by all the videos I put out. Put a comment down in the comment section. Let me know what you think. And if you've got any questions, thanks for joining me. Have a great day.